Hey everyone, so this is going to be like the review video for test one. Sorry I'm kind of recording this a little later than I expected. I was hoping to do it yesterday, but I didn't really get many questions, so I was kind of hoping I would get more. And then today, Sundays just kind of are a little busy for me, but I'm doing it now. So test one, I have like a review document and I'm going to post this as well, but I thought I would just kind of go through it with you guys. So, disclaimer, of course, not everything on the test is here, but hopefully this will just kind of give you a base of where to start. So, first, talking about angles, make sure you know how to convert from radians to degrees. You'll definitely need to know these common angles of like 0, 90, 180, 270, 360, knowing what those are in radians, and then also knowing 30, 45, and 60. So it's pretty quick. With that, also, it's not written on here, but coterminal. Coterminal is something that we talked about a good bit, so make sure you kind of know what that is and how to find coterminal angles and stuff like that. Next is kind of your angles and functions that you're responsible for knowing. So this is like in sine and cosine at 0, 90, 180, 270, and 360. Also, you'll need to know sine and cosine at 30, 45, and 60. Now, I really just put sine and cosine on here because if you know sine and cosine, you can figure out any other one, right? Because tangent is sine over cosine. So as long as I know those, I can figure out tangent. I might write something down in a second about this, but I'm just going to kind of run through for a little bit and then I'll kind of look over the notes as well. Also remember that you can find other angles on the unit circle by using reference angles, and I'll come back to that a little bit more in detail. Some other relationships that you'll need to know is like sine, cosine, tangent, that is opposite over hypotenuse, adjacent over hypotenuse, and then opposite over adjacent, respectively. Knowing cosecant, cotangent, all of that kind of stuff is all stuff that you are responsible for knowing. Also, the fundamental identity, which I have written here, which is sine squared plus cosine squared equals 1. That one's huge. You definitely need to know that. I also wrote on here the like all students take courses thing, and that's to remember which ones are positive and which ones are negative in which quadrants. Now it's all based off of which ones have X. Oop, I didn't mean to erase there. It's all based on like which ones have X and then which ones have like positive X and negative X, which ones have positive Y and negative Y. And you can always come back up here to like these relationships to figure that out. I didn't mean to erase that. I was just trying to write a line, but then let's keep going. Oh, some formulas, some things that you'll need to know. So arc length, I do give this formula. Area of a sector, I give this formula. Always remember that alpha needs to be in radians, so if it's given to you in degrees, you'll need to convert that before you can actually do the problem. Also be careful for times that maybe you're being given diameter instead of radius, because you want to, divide it by 2 to get the radius. Then we've got 1.3, which is angular and linear velocity. Someone did ask me to do a problem from that, so I have one written down for us to do. Really, these are mostly conversions. So you're usually going to start with revolutions over some time, and then you'll multiply by this conversion here to get into radians. You'll do that for both angular and linear. Now, the difference between the two is that angular velocity, you leave it with radians. Like that's part of your final unit. However, linear velocity, you have to multiply by the radius because you're going to want an actual distance as part of your unit. And so we'll do a problem like that, but that's really the difference between the two. Is angular, you're not going to multiply by the radius. Linear, you will have to multiply by the radius. And then lastly, we'll talk about graphing. So usually when we graph, you'll want to use radians. I need you to know how to graph sine, cosine, and tangent. I wrote a bunch of stuff on here, a bunch of the formulas and stuff like that. For the finding x values, I usually, for sine and cosine, I set the inside of my parentheses equal to the quadrantal angles, which is 0, pi over 2, pi, 3 pi over 2, and 2 pi, and then I solve for x. For the y values, I really just plug in the x values. Now, when you're more familiar with finding y values, there are steps that you can skip. You can kind of skip actually plugging in the x's and stuff like that. I think that would be better if I show you an example rather than just kind of talking about it. So I'll do that. And then also remember that if you ever need more points, like for instance with tangent, we need more than just the quadrantal points. So what we do for that is we take two of our points, add them together, divide by 2, and then we can find more points like in between. So let me go ahead, that was it for like kind of the basic review document. And now I'm just going to go over to our notes, and I think I just want to like talk through some of this. I'm just going to scroll up and kind of see if anything kind of shoots out at me as, oh, I should go over this. So I'm just going to kind of walk through, I guess. Let's see. All right, looking at 1.1. I mean, remember that counterclockwise is going to be positive, clockwise would be negative. Knowing some angles, we talked about coterminal here, so that's great to go over. The nice thing is you can always rewatch these videos. You know, if there's something that didn't make sense to you, you can always rewatch. 1.2 is when we do radians, arc length, and area of a sector. I have the conversions here for radians, and we did some practice of changing angles from radians to degrees and vice versa. I think that's good. Again, arc length, I will give you that formula, which is the angle times the radius. And then I would say knowing how to do these kinds of problems, just make sure that you know that on the test, I do try to make the problems where they can be done with no calculator. So I would say this one right here, part B, is a great problem for arc length because you don't actually need a calculator to do it. And what I mean by that, like on the test, right? So it'll say, leave your answers exact, meaning no decimals. So I'll want just 7 pi over 3. Like for this answer, I would have just left it like this. I don't need this. Now, if you give me this, it's fine. Like if you do put it in, but you'll have to be careful because there's going to be some problems where you might lose credit if you give me the decimal answer. We'll hit some like that and I'll point it out to you. Area of a sector, I give you that formula. Angular and linear, mostly just conversions. Except with linear, you have to multiply by the radius. 1.4 is a huge section. Like I said when I did the video for that one, you really can't do anything else in the course if you can't do 1.4. Like it really is one of the most important sections that we do. I say definitely expect to see something like maybe like example 1. That's a pretty good question, or maybe something similar to it, just where you have to like find all the other trig functions. Definitely some like example 2 where we have to do like sine at a certain angle, cosine at a certain angle, tangent at a certain angle, secant, whatever it is. Definitely some like example 3, and then also what I'm guessing will be example 4. I would 100% go back and look over these. Make sure you can do problems like these. So like sine 135, I'll talk through it a little bit. I'm talking about part A right now. So 135, first we figure out what quadrant it's in, and then we always want to figure out how far is it from the x-axis. So the nearest x-axis would be 180. So 180 minus 135 would be 45. So that tells us that sine has a reference of 45 degrees. So on the test, I can ask you for the reference angle. What I'm looking for is how far is it from the x-axis. Never ever the y-axis, always the x-axis. And also that helps me be able to go back up here and say, okay, well, instead of thinking about sine of 135, I can just think about sine of 45, which is square root 2 over 2. So 135 would also be square root 2 over 2. The only thing that can change is the quadrant. So like the sine. Oop, I kind of scrolled up on accident. Sorry about that. Let me go back down. So for instance, sine of 135 is in quadrant 2, and sine is positive in quadrant 2. So we still have a positive answer. But if we go look at part B, 5 pi over 4, our reference is pi over 4, or 45 degrees. So cosine of 5 pi over 4 is square root 2 over 2, just like cosine of pi over 4 is square root 2 over 2. The only thing that changes is that the sign has to be negative since we're in quadrant 3. Same story for 30 and 60. You can always measure how far is it from the x-axis. That's the reference angle. And then I gave this table to kind of help out with those. So if any of this is you're like feeling weird about or anything like that, I really would recommend going back and rewatching the 1.4 video. The 1.5 video as well is pretty good. Very important stuff. We get more into word problems. Example 1, I would say it's likely you could see something like that on test 1. Also maybe example 2, that's a great one. Angle of elevation and angle of depression. That's something great to review. Remember that these angles are equivalent to each other, and they should always touch the horizontal. So for angle of depression, sometimes, I'll have people draw their triangle and they put the angle of depression right here. That is incorrect. I know it's incorrect because it's not touching the horizontal. What we should do in a case like this, if we're given the angle of depression, is we need to draw kind of this invisible line up here. This is the angle of depression, and then also this would be the angle of depression. Well, what it's equivalent to, which is the angle of elevation. So just something to think about. Make sure your angle is always touching the horizontal, never ever the vertical. And I gave a good example of that with example 3. So you can always go back and look at that one. You will not have a problem on the test like example 5. I think it's a great one for us to go over, but it is a bit too long for our test. So I would not worry about example 5. I would spend more time on examples 1 through 4, being able to do those. 1.6 is a great section as well to go over. This one we did the fundamental identity problem. I would go back and look over example 1. Put a star by that one. If I ask you to use the fundamental identity, I need you to use it to get full credit. Now, if you use a different method and you get the correct answer, you will probably lose like a point or two, but it's still better than leaving it blank. So even if you have to use a different method, that's okay. I would just go with that. But to get full credit, you would have to use the identity if I ask you to. Reference angles, here's the definition for reference angles, and it pretty much just describes how far is it from the x-axis. And we did a bunch of problems like this where I gave the reference and stuff, and then I did some where I actually did a trig function with it. 1.6 is really good to go over as well for these types of problems. Just be aware that I could really ask you anything on the unit circle. So I put a picture of one in here. And so I can ask you sine, cosine, tangent, cotangent, cosecant, secant of any of these angles. I can ask you in radians, I can ask you in degrees, but I can ask you for any of these angles. So just be prepared for that. And then, oh, it kind of went over weird. All right. Next, we started talking about graphing. And so I'll just kind of jump to a problem that we did. So here we graphed sine of x minus pi over 2 plus 1. And I showed how to find the x values. And then I also showed actually plugging in the y values here. Now later in our next section in 2.1, I'm sorry, 2.2. In 2.2, I started to skip to this step right here. Hopefully you can see where I just wrote. I started skipping over to this and not showing any of this work. That's fine for you to do as well if you're comfortable with it. If you're not comfortable with skipping steps, then don't do it. Just go through the process of actually plugging in your x and you'll be better off. Again, with cosine, it just changes the general shape. Graph one cycle, find the period, any transformations, the range. So we did all that for this one as well. Now, this is where we started 2.2. The only difference between 2.1 and 2.2 is in 2.2 I started adding in a b value. But the actual process was all the same. But I did, as you can see, like what I just brought up a second ago, I started skipping steps right here. Like for the y values, I know what the original values that sine goes through are, which are 0, 1, 0, -1, 0. And so I just plug those in instead of going through the process of plugging in the whole x value and all of that. Again, please don't feel like you have to skip steps if you're not comfortable doing it. You can always just plug the actual x value into the original problem and like simplify that way. But yeah, if you need anything on these, I would just go back and watch those videos. I will not ask you how to graph cosecant or secant. I know I showed it in 2.3, but I will not be asking you for those. So truthfully, I'm just going to skip over it during our review. 2.4 is graphs of tangent and cotangent. And remember that cotangent and tangent have a different period. So their period is pi over b instead of cosine and sine, which is 2 pi over b. So something to remember. Also with tangent, you'll find that using just the quadrantal angles doesn't give you enough x values. So for instance, I'll show you on this problem we did. I'm looking at part A right now. So I set all of my x values equal to 0, pi over 2 pi, 3 pi over 2, 2 pi. What I found is that these don't actually matter because they're outside of one period. So between the asymptotes is going to be one period. So we found that our starting value for our graph was actually this one, and our last one was this one, because that's where our asymptotes are. So that's where we're going to see one cycle of tangent. So to be able to get more points out of this, I used midpoint method, which is where you add the two angles together and then divide by 2 to find more like in between them. And then again for tangent, I did show in this problem like actually plugging in the values and simplifying and everything. However, later I did skip a little bit and I showed how to just do it using transformations. And that's usually what I would do when I graph tangent, is at least for the y values, I would use transformations. Meaning just looking at like what, oh my goodness, that is the worst thing that I do on here. Is like when I accidentally erase. I need to just turn this setting off where when you like tap the pin, it switches, because it bothers me too much. I do it too many times on accident. Okay, sorry. Anyway, by using transformations, what I mean is like saying, oh, the vertical shift is +1, so the middle of the graph should go through 1. The amplitude is 2, so that means the difference between my y values should be 2. So that's what I mean by using transformations to draw the graph. Now I'm not going to ask you about cotangent, so I won't go over it in the review either. Now I really didn't get any questions from anyone except for one about 1.3, so I'll just kind of give you a rundown of what I commonly see, like issues I see. 1. Stuff like this. I'll write it underneath this problem. I'll see stuff like, if I ask sine of 3 pi over 4, I don't know, something like this. Sometimes what I'll get is people will just say pi over 4. They'll just give me the reference. Or sometimes they convert it to degrees. This in degrees would be 135 degrees. Sometimes I get these as my answers. This is not what I'm looking for. What I'm looking for is the actual value that sine has at that angle. So of course, if you typed in your calculator, you're going to get a decimal. That's not what I want. I want you to do it how we did it in class. So this is pi, this is 0 or 2 pi. I can change this to 4 pi over 4. This would be 8 pi over 4. 3 pi over 4 would come right before 4 pi over 4s, so it ends up in this quadrant. Then I measure how far is it from the x-axis. So this one is pi over 4. And then usually you would go to like your table or however you've remembered these. So I gave you this to try to help you remember it. I said, okay, I did 30, 45, 60. 30 is pi over 6, 45 is pi over 4, 60 is pi over 3. And this is 1 over 2, root 2 over 2, root 3 over 2, root 3 over 2, root 2 over 2, and 1 over 2. So since our reference is pi over 4, I'm going to look at pi over 4, and I'm looking for sine. So sine. So this is root 2 over 2. And then I want to remember to check if it's positive or negative. Since it's in quadrant 2, sine is going to be positive there. So that's my final answer. So people do really mess up on those. Also the graphing. People often mess up on the graphing. So just be careful while you're doing these. You know, the online classes, they're a little rough in the way that I don't really get as many questions, but during the school year, you know, the regular school year, I have a lot of questions during class and stuff. So I definitely feel like I have a little bit more concern for the online students when I'm not getting the same amount of feedback as like a normal quarter. You know, hopefully you know what I mean. Like, I'm just hoping that everything is going okay for you, and I also hope that if it's not, you please let me know so I can try to help you out. So that is a big one. Knowing how to do those, knowing how to graph, those are big. Like it's a lot of points that the test is worth out of those. Let me give you a little bit of information about the test. So the test will have, I think it's roughly like 20-ish questions. It's hard to say. It's like usually about 15 to 20. It's hard to say because there's parts. So I really go more off of like time. So for your test, you have an hour and 15 minutes. I do that because a normal quarter would be like a Monday, Wednesday, Friday class, and we would do an hour and 15 tests. So I try to just structure it to where it'd be the same if we were doing a normal quarter. So you have an hour and 15, and so I kind of just base it off that more than like number of questions per se. And yeah, because there's parts and stuff like that. I'll tell you for sure there's a sine graph, a cosine graph, and a tangent graph. So you got 3 graphs on there. I'll tell you for sure that there's a bunch of these problems, kind of like just, you know, variations of this type that we did in 1.4 and 1.6. There's an area of sector, there's a arc length, there's an angle of depression, there's an angle of elevation problem. So that's kind of a little rundown, at least, of what you'll see. So let me go ahead and do this 1.3 question that I got a question about. So I just made this one up. I think they just wanted to see like just another example. So I already wrote it. It says the blade of a saw rotates at 40 rotations per second. The diameter of the blade is 12 inches, and we need to find the angular velocity in radians per minute, and we'll find the linear velocity in feet per minute. So for our angular velocity, I start off that it's 40 rotations per second. Sometimes they'll say rotations or revolutions. I think I based this off of my MATLAB problem. Oh yeah, I did. Look, they said revolutions, but I put rotations. That's my bad. I try to structure it the same, so I should say revolutions, but those are pretty much meaning the same thing. So let me put a note here. Instead of rotations, this really should say revolutions. Oh my gosh. I'm kind of a terrible speller. Hold on. Embarrassing. Okay. Oh, it's not going on my thing. Well, this is a background of my thing, and you can see my dogs. Sorry about that. Revolutions. So sorry I said rotations. I try to keep it consistent, like with the test and the homework problems and stuff. So I just changed this problem like from a MyMathLab problem. So it's 40 revolutions per 1 second. And I'm trying to get this in radians per minute. So to get revolutions to radians, I have the conversion that 2 pi radians is 1 revolution. Now revolutions is canceled and I have radians, so that's great. but I want per second, and right now I want per minute, right now I have per second. So I'm going to multiply, and I know that 1 minute is 60 seconds. And the reason I put seconds at the top is so that it would cancel out with the seconds earlier. And then we'll multiply. So let's see, this would be 40 times 60. So that's going to be 2,400, and then times 2, so 4,800. So this will be 4800 pi, and this is radians over minutes. And that's all I would look for. That's where you would leave it. Linear velocity is very similar. I'm still going to start at 40 revolutions per 1 second. I still need to multiply by 2 pi radians over 1 revolution. Revolutions cancels. But now I'm trying to get feet per minute. That should also tell you, oh, I need to have like a distance in here. Well, linear velocity, you have to multiply by the radius. So the diameter is 12 inches. So that means the radius would be 6. So I'm going to multiply by 6 inches. And I'll just put that over 1. Now I'm supposed to go from inches to feet. So I know that 1 foot is 12 inches. And then if I keep going, I need to get seconds to minutes, so 60 seconds over 1 minute. So let's see, we canceled out inches, we canceled out revolutions, we canceled out seconds. So for my final answer here, let's see, I would get 40 times 2 pi times 6 times 60, all divided by 12, and that's in feet per minute. Now I'm going to reduce this, but I just wanted to write it out first. 2 and 6 will cancel out this 12. So this one I get 40 times 60, which would be 2,400 pi, and this is feet per minute. And that would be it. So I feel like this is a pretty good example of like what you would see on the test, especially because you don't need a calculator for it. However, you're welcome to have one. Just make sure it's the approved calculator from the syllabus, which is the TI-30 XIIS. And then one more thing I wanted to mention that I forgot to, in 1.5, I get a lot of times that people will give me those answers. Like for instance, example 4, people will give me that answer in decimals. I don't want that answer in decimals. And when I say no decimals, that doesn't mean plug it into your calculator and then just don't put any decimal points. It means I want the exact answer. The reason is because when you see that sine of 45 degrees, we know sine of 45 degrees. We have the exact answer for it, which is root 2 over 2. So what I'm looking for is for you to keep it with the square roots. Same idea with example 3. Sometimes I'll get people plugging this into the calculator. You will lose credit for that because tangent 30, like we know what it is, So make sure that on your test, you always leave things with exact answers. Really, you shouldn't use decimals for anything because I mean, in the directions it says no decimals, leave your answers exact, which means with fractions or square roots. So I hope that makes sense, and I hope y'all don't make that mistake. But it is a pretty common one that I'll see. So I'll go ahead and, I'll post this video obviously, and then I will also have posted this document to maybe just help you out a little bit, with things that at least you have to remember. So I guess that's it for this video. I am hoping that you'll do well on our test. Also remember that test 2 is Tuesday, the 24th. It was originally scheduled for Monday, but I had to move it because I got called for jury duty on Monday, so I had to move the test around a little bit. So your test is Tuesday, not Monday. All right, so good luck. Let me know if you're needing anything.